In this video, we'll start to look at other ways we can use matrices or two-dimensional arrays. Let's start by opening up a new script. I'm going to save all my commands again and we'll see how that goes. So I'm going to call this, I'll use 2% signs for my header row to start a new cell. I'll call this manipulating matrices. So far we have seen some matrices, but now it's time to start doing more things with them. So we've seen some matrices, now we're going to get more in-depth. Let's look at ways to define a matrix. Define a matrix or two-dimensional array. Same thing, I'll use those words interchangeably. Here's one way. I'm going to use capital letters for my matrices. Let's run this section and see what we get. This is technically a matrix. I know I said we were going to use two-dimensional matrices, but I used square brackets and I got a 1-by-1 matrix. Let's take a look at a slightly larger one, 1, 3, or use a comma. We can also define it with the comma 1, 3. Let's get a bigger one. Let's say C equals, and we'll use square brackets again, but this time I'm going to use a semicolon instead of a comma. So when I use a semicolon, that brings us to the next row. I've got to be careful here to enter 3 elements in each row. So let's make a note here. Semicolon means new row. What else can we do? Another way to define a matrix is to use the enter key. So I can say -1, 0, 3, and hit enter. And it takes me to the next row. So even though I didn't use a semicolon, using the enter key will let MATLAB know that we want a different row. So I can say 301, hit enter again, 2, -2, 12. I could keep going, but let's end it there. So those are all ways of defining a matrix directly, but we can also build matrices from other matrices. So one way to do this, let's run this section so I get my variables in the workspace to play with. Let's create a new one called E, and we'll make it out of using C and B together. So C, comma, B. Comma, remember, is not a new row, it's putting it side by side. So this is telling MATLAB to take the matrix C and use that on the left, and then on the right of that, use matrix B. Now I don't think it's going to work, and we'll see if we can figure out why. So let me suppress all of this. Well, actually I don't even need it anymore, but that's okay. Let's just run it and see what we get for E. E. Dimensions of the arrays being concatenated are not consistent, I think is probably what that says. Consistent. It doesn't match. I can't put a 1-by-2, which is what B is, next to a 3-by-3, which is what C is. MATLAB doesn't know what to do with all the empty spaces. So this doesn't work because the dimensions are not compatible. We need them to be the same height if we want to put them side by side. And since we don't have that, it doesn't work. Let's try it. I'm going to comment this one out. And let's try again. Let's try with something called F. I'll take A and I'll put it next to B. Remember, MATLAB is caps sensitive, so we have to use capital letter A, capital letter B. All right, F equals A, B. Let's see what we get on that one. Run section. This one works. I've got A, which is just this 1-by-1, and then I've got B. Because they both have a height of 1, they go side by side with no problem. So this is how we can build a matrix out of other matrices or scalars or vectors if the dimensions are compatible. Could we have put A on top of B? That would not have worked because they do not have the same width. A and B do not have the same width. They have the same height, but not the same width. Let's see. Let's do something slightly different. What if I did F equals F comma A? Is this allowed? Is this going to work? It's still going to do this, build F out of the A and the B. And then it's going to take that value of f and use it again right here. Is it the same height as A? Yes. So will it work? Yes. We got our f, and to the right of that, because I have this to the right of f, I got one extra column that represents matrix A. So we can continue going like that if we wanted to, but let's try something different. Let's use, let me type a note here, the semicolon to make a new row. Remember we said commas are for side by side and semicolons are for new rows. That has the effect of stacking the matrices on top of each other. So notice, let's see if which ones have the same width. Remember the number of columns is the second number. So width is another way of saying how many columns are there. So we want the second number. Looks like C and D will be compatible. Even though they have different number of rows, they should be able to stack on top of each other. So I'll use C semicolon D. And I do want to see what this one is. We're probably going to need a little more room since there are going to be 7 rows. But let's run the section and take a look at it. So what we have here, the first 3 come from the C. That was my original C, a 3 by 3 matrix, and we can double click on it and look at it if we want to. There it is, just like that. And then D, if I want to double click on that and look at that in the editor window, I get this bottom part. So C is stacked on top of D. Let's close that window and go back to here. So that's how we can stack matrices on top of each other, or if we have the same width and it's single rows, we can put rows together also. All right, that's enough for right now. I'll see you again in the next video.